Welcome to my channel VKSCAM tutorial. In this channel, I usually upload the important topics in organic chemistry for UG and PG level students. It will also helpful for those who are preparing for CSIR, NET, JRF and GATE examination. Please watch the video completely, and if you think it is helpful, please like, share, and if you are new in watching this channel, please subscribe. Okay, in this video tutorial I will discuss the McLafferty rearrangements in mass spectrometry by taking some of the important examples of alkenes, alkynes, aldehydes, ketones, amides, etc. Okay, McLafferty rearrangement involves the migration of gamma hydrogen followed by the cleavage of a beta bond. The rearrangement leads to the elimination of a neutral molecule from aldehydes, ketones, amides, unsaturated compounds, substituted aromatic compounds, etc. The rearrangement proceeds usually through a sterically hindered six-membered transition state. This can be described by taking these examples. See the example. It is a ketone with the gamma hydrogen atom. It is alpha carbon, it is beta, it is gamma carbon. You can see here is a gamma hydrogen atom. It gets abstracted by this oxygen of molecular ion. Thereby pi electron is shifted here, and this beta carbon atom thereby cleaved by shifting this bond between this carbon atom, and thereby we will get this highly strained transition state, six-membered transition state. Then this transition state decomposes, producing this ion. It is what is called the McLafferty ion, McLafferty rearrangement ion, MR ion. You can see it is a radical cation. It is a radical cation. You can see a dot of free radical and the cation, and so it is a radical cation. Usually McLafferty rearrangement ion is radical cation, and through this reaction a neutral molecule, usually an alkene, is also produced. You can see this is the alkene formed here. Then we can take each of the example. The first is an alkene having a gamma hydrogen atom. For example, it is alpha and it is beta. Then you can see it is the gamma hydrogen. This gamma hydrogen is abstracted by this unsaturated carbon atom, thereby bond shift here. Also the beta bond is cleaved to form an alkene. A neutral alkene molecule is eliminated. Thereby we will get the McLafferty rearranged ion. In this case the M/E value is 56. You can see the molecular mass of this McLafferty rearranged ion is 56. Along with this McLafferty rearranged ion, a neutral alkene molecule is also produced. That is the characteristic of McLafferty rearrangement. Then we can take an example of alkyne. Here also it is the gamma hydrogen atom. It gets abstracted by this unsaturated carbon atom, and the pi bond is shifted in between this carbon atom. Also this beta bond gets cleaved, eliminating a molecule of propene. Along with the formation of the McLafferty rearranged ion, in this case you can see the M/E value is 54. It is produced along with the neutral molecule propene. Okay, then if you take a substituted aromatic compound, it is propyl benzene. You can see here is also gamma hydrogen atom on the gamma carbon atom. This is the gamma hydrogen atom, and it is abstracted by this unsaturated carbon atom. Thereby the pi bond is shifted towards here, along with the cleavage of this beta bond, forming the McLafferty rearranged ion. This McLafferty rearranged ion along with the neutral molecule propene. It is the McLafferty rearranged ion. Here is a dot and also a positive charge. You can also depict this McLafferty rearranged ion like this also, plus and radical. Instead of putting these signs here, you can represent the McLafferty rearranged ion like this also. Here this McLafferty rearranged ion having molecular mass 92, and it is produced along with the neutral molecule propene. Okay, next see these examples of an aldehyde. It has gamma hydrogen atom. It is the gamma hydrogen atom at gamma carbon atom. It is alpha, beta and gamma, and this gamma hydrogen atom is abstracted by this molecular ion of an aldehyde. Thereby the pi bond is shifted in between this carbon atom, alpha carbon carbon bond, along with the breakage of this beta carbon 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 bond, thereby forming a McLafferty rearranged ion and the neutral molecule alkene. You can see it is the McLafferty rearranged ion formed from this molecule. It has M by E value 44 along with the neutral molecule propane. Similarly, if you take the examples of ketone, this ketone having gamma hydrogen atom, it is the gamma hydrogen atom, alpha, it is beta, it is the gamma carbon atom. Thereby this hydrogen, gamma hydrogen is abstracted by this oxygen of the molecular ion. Thereby the pi bond is shifted in between alpha carbon carbon bond, and along with the beta bond is broken, thereby forming the corresponding McLafferty ion. This McLafferty ion having M by E value 58 along with the neutral alkene molecule. Okay, then we can take the example of acid also having gamma hydrogen atom. This acid, carboxylic acid having gamma hydrogen atom, it first abstracted by this oxygen atom of the molecular ion of this acid, carboxylic acid, whereby this pi bond is shifted here along with the breakage of this beta bond, forming the corresponding molecular ion, the McLafferty rearranged ion with M by E value 60. A neutral molecule is eliminated. This neutral molecule is usually an alkene, in this case propene. Okay, then consider the example of an ester. This ester having gamma hydrogen atom, and this gamma hydrogen atom, it is the gamma hydrogen atom and the gamma carbon atom. It is abstracted as in the previous case by the oxygen atom of this molecular ion, whereby this pi bond is shifted here along with the breakage of this beta carbon carbon bond, forming corresponding molecular ion which is called McLafferty rearranged ion with the elimination of corresponding alkene. Here it is propene. Okay, if you take the example of an amide, it is an amide which having a gamma hydrogen atom. This gamma hydrogen atom is abstracted by the oxygen atom of the molecular ion, whereby the pi electron is shifted here along with the breaking of this beta bond, forming the corresponding McLafferty rearranged ion with M by E value 59, liberating or eliminating the corresponding alkene. Here also it is propene. Then if you take a ketone having gamma hydrogen atom on both sides of the functional group, you can see it is the gamma carbon atom. Here also gamma carbon atom is here with gamma hydrogen atom. Thereby a double McLafferty rearrangement takes place with the elimination of corresponding alkene, forming first this McLafferty rearranged ion, and this McLafferty rearranged ion also having this gamma hydrogen atom. It is alpha carbon atom, it is beta carbon atom, and it is the gamma carbon atom, and this gamma carbon atom having gamma hydrogen which will be abstracted by this unsaturated carbon atom, whereby this pi bond is shifted towards here, and this beta carbon carbon bond gets cleaved to forming for forming the corresponding alkene. Here it is ethene, along with this second McLafferty rearranged ion, this McLafferty rearranged ion. Okay, so these are the some of the important examples of McLafferty rearrangement, and I have already discussed the examples from alkenes, alkynes, aldehydes, ketones, esters, amides, substituted benzene. Also, an example of double McLafferty rearrangement. Okay, here I conclude my video. Thank you for watching.